calculate the appropriate service size, it's crucial to consider the load calculation per unit and the number of units being served. Based on a load of 160 amps per unit and 5 units, the total load in the service would be 160 amps multiplied by 5 units, equaling 800 amps. It's important to also account for any additional loads, such as the house panel, if applicable. In this scenario, the information provided doesn't specify known loads for the house panel, so we'll assume that the load is negligible for the purpose of this calculation. Therefore, the minimum service size required is 800 amps. Now, let's consider the CT cabinet configuration. Using the CT cabinet as a junction box with lug blocks to connect parallel 400 mcm copper conductors to each set of 3/0 copper conductors to feed each meter is acceptable. With 3 parallel 400 mcm copper conductors, you would have an ampacity of 600 amps per phase. Since there are 6 main disconnects, a master disconnect is not required. Beyond these calculations and configurations, several additional factors must be taken into account. Firstly, short circuit calculations are essential. It's crucial to ensure that the service conductors and equipment can withstand the available short-circuit current at the location. Performing short-circuit calculations helps determine the necessary current ratings for the equipment. Secondly, CT ratings need verification. It's important to verify that the CT current transformers in the cabinet are rated for the maximum load current, which in this case is 800 amps. Thirdly, conduit size is a critical consideration. Select conduit sizes that are large enough to accommodate the number of conductors and the required bending radius. This ensures that the conductors are not damaged during installation and that the conduit can effectively protect the conductors. Fourthly, proper grounding is paramount. The service must be properly grounded according to applicable codes and standards to ensure the safety of the electrical system and prevent electrical hazards. Fifthly, ensure you obtain all necessary permits and inspections to ensure proper installation and compliance with local regulations. This helps ensure that the electrical installation meets all safety standards and that it's installed correctly. When considering conductor ampacity, it's essential to consult the National Electrical Code, NEC Table 310.15b16 or the appropriate table for your specific situation. This table provides the allowable ampacities of insulated conductors rated up to and including 2000 volts 60 degrees Celsius to 90 degrees Celsius in free air, based on ambient air temperatures. For example, according to NEC Table 310.15b16, a 3/0 copper conductor with a 75 degrees Celsius insulation rating has an ampacity of 200 amps. When paralleling conductors, it's important to adhere to the requirements outlined in NEC Section 310.10h. This section specifies the conditions under which conductors can be run in parallel. Firstly, all the parallel conductors must be the same length. Secondly, they must be of the same conductor material. Thirdly, they must be the same size and circular mill area. Fourthly, they must have the same insulation type. Finally, they must be terminated in the same manner. The overcurrent protection for the parallel conductors must also comply with NEC requirements. The overcurrent protection device must be sized to protect the conductors in accordance with their ampacity. Additionally, the overcurrent protection device must be readily accessible and located where the conductors receive their supply. When using a CT cabinet, it's important to understand the function of current transformers, CTs. CT are used to measure the current flowing through a conductor without directly connecting to the conductor. They provide a scaled-down current signal that can be used by metering equipment to measure the current. The CT in the cabinet must be rated for the maximum load current to ensure accurate measurement. The primary current rating of the CT must be equal to or greater than the maximum load current. The secondary current rating is typically 5 amps. The CT must also have an appropriate burden rating. The burden is the impedance of the metering equipment connected to the CT secondary. The CT burden rating must be equal to or greater than the impedance of the metering equipment. When selecting lug blocks for the CT cabinet, it's important to choose lug blocks that are appropriately sized for the conductors being used. The lug blocks must be rated for the ampacity of the conductors and must be compatible with the conductor material. Additionally, the lug blocks must be properly installed to ensure a secure connection. The lug blocks must be tightened to the manufacturer's specified torque to prevent loose connections. When selecting conduit for the service conductors, it's important to consider the number of conductors, the conductor size, and the ambient temperature. The conduit must be sized to accommodate the conductors without exceeding the conduit fill requirement specified in NEC. The conduit fill requirements are based on the percentage of the conduit's cross-sectional area that is occupied by the conductors. The ambient temperature also affects the ampacity of the conductors. The ampacity of the conductors must be derated if the ambient temperature exceeds 30 degrees Celsius, 86 degrees Fahrenheit. The derating factors are specified in NEC Table 310.15b2. When grounding the service, it's important to comply with the requirements of NEC Article 250. This article specifies the methods for grounding electrical systems. The grounding electrode system must consist of one or more grounding electrodes. The grounding electrodes can be a metal underground water pipe, a concrete encased electrode, a ground ring, or other approved electrodes. The grounding electrode conductor must be sized in accordance with NEC Table 250.66. The grounding electrode conductor must be connected to the grounding electrode into the equipment grounding bus in the service equipment. The equipment grounding conductors must be sized in accordance with NEC Table 250.122. The equipment grounding conductors must be connected to the equipment grounding bus in the service equipment and to the metal enclosures of the electrical equipment. Additionally, surge protection devices, SPDs, can be installed at the service to protect the electrical equipment from voltage surges. SPD are designed to limit the voltage that can appear on the electrical system. SPD are typically installed at the service entrance and the downstream panels. The selection of SPD depends on the voltage and current rating of the electrical system and the expected surge levels. When performing short circuit calculations, it's important to use accurate data for the electrical system. The short circuit calculations must take into account the impedance of the utility transformer, the service conductors, and the branch circuit conductors. The short circuit calculations can be performed using software or by hand using the point-to-point method. The short circuit calculations must be used to determine the interrupting rating of the overcurrent protection devices. The interrupting rating of the overcurrent protection devices must be equal to or greater than the available short circuit current at the location. When selecting overcurrent protection devices, it's important to consider the type of load being served. Different types of loads require different types of overcurrent protection devices. For example, motor loads require overcurrent protection devices that are designed to handle the high inrush current of the motor. Lighting loads require overcurrent protection devices that are designed to protect against overloads and short circuits. The overcurrent protection devices must be sized in accordance with the NEC. The overcurrent protection devices must be readily accessible and located where the conductors receive their supply. When installing the electrical equipment, it's important to follow the manufacturer's instructions. The manufacturer's instructions provide detailed information on how to install the equipment correctly. The equipment must be installed in a location that is accessible for maintenance and repair. The equipment must be protected from physical damage. The equipment must be properly ventilated to prevent overheating. When inspecting the electrical installation, it's important to look for any signs of defects or damage. Check for loose connections, damaged conductors, and overheated equipment. Verify that the overcurrent protection devices are properly sized and installed. Verify that the grounding system is properly installed. Verify that the equipment is properly labeled. If any defects or damage are found, they must be corrected immediately. Finally, always remember safety when working with electricity. Always de-energize the electrical system before working on it. Use appropriate personal protective equipment, PPE, such as gloves, safety glasses, and insulated tools. Never work alone. Be aware of the potential hazards of electricity and take steps to protect yourself. Ensure all work complies with the latest edition of the National Electrical Code and local amendments. Always consult with a qualified electrician if you are unsure about any aspect of the electrical installation. Consider the potential future expansion of the electrical system. Designing the service with extra capacity can save costs in the long run if additional units or loads are added later. This foresight can prevent the need for a complete service upgrade in the future. Review local utility requirements for service connections. Different utilities have different requirements for service entrances, metering, and disconnects. Contacting the local utility early in the planning process can help avoid delays and ensure compliance. Consider energy efficiency measures when designing the electrical system. Using energy-efficient lighting, appliances, and HVAC systems can reduce the overall load on the service and lower operating costs. LED lighting, for example, consumes significantly less energy than traditional incandescent lighting. When calculating the load for each unit, consider the specific appliances and equipment that will be used. Using accurate load data for each appliance and equipment can help ensure that the service is adequately sized. For example, if a unit will have a large electric range or dryer, this should be factored into the load calculation. Ensure that the panel boards in each unit are adequately sized for the expected load. The panel board should have enough circuit breakers to accommodate all of the circuits in the unit. It is also a good idea to have some spare circuit breakers for future expansion. When running the conductors from the CT cabinet to the panel boards in each unit, use appropriately sized conduit and pull boxes. The conduit should be sized to accommodate the number of conductors and the required bending radius. Pull boxes can be used to make it easier to pull the conductors through the conduit. Label all of the conductors and equipment clearly. This will make it easier to identify the conductors and equipment in the future. Use a permanent marker or label maker to create the labels. Clearly label each circuit breaker in the panel boards with the corresponding load that it serves. This will make it easier to troubleshoot electrical problems in the future. Provide the customer with a detailed electrical diagram of the service and the panel boards in each unit. This will help them understand the electrical system and how it works. The electrical diagram should show the location of all of the equipment, the size of the conductors, and the rating of the circuit breakers. Provide the customer with a list of qualified electricians who can provide maintenance and repair services for the electrical system. This will help them find a qualified electrician if they need one in the future. Consider the use of smart meters. Smart meters can provide real-time data on energy consumption, which can help the customer manage their energy use and lower their bills. Smart meters can also be used to remotely disconnect and reconnect service, which can be useful for managing tenant turnover. Finally, remember to document everything. Keep detailed records of all of the calculations, specifications, and installations. This documentation will be useful for future maintenance and repairs, and it will also be helpful if there are any disputes or legal issues. Make sure the customer understands the limitations of the electrical system. Explain to them what they can and cannot do with the electrical system. For example, explain to them that they cannot overload the circuits or tamper with the electrical equipment. Address the importance of regular electrical inspections. Encourage the customer to have the electrical system inspected regularly by a qualified electrician. Regular inspections can help identify potential problems before they become serious. Review warranty information for electrical components. Provide the customer with warranty information for all of the electrical components, such as the panel boards, circuit breakers, and wiring. In summary, accurately calculate the service size based on the anticipated load, properly configure the CT cabinet and conductor paralleling, and carefully consider all additional factors such as short circuit current, CT ratings, conduit sizing, and grounding. Always prioritize safety and compliance with applicable codes and regulations.